Hello and Assalamualaikum. My name is Muhammad Nizar Azrai Putra bin Muhammad Nazri. My metric number is 08DEP22F1123. Introduction. A stationary point is a location on a curve or function where the derivative is equal to 0. In other words, the slope of the curve is flat or horizontal at the point instead of positive or negative. Maxima and minima are the two different categories of stationary point. A maxima is a point at which the function changes from increasing to decreasing, while a minimum is the point at which the function changes from decreasing to increasing. On the other hand, rate of change describes how quickly a quantity changes over time. It can be described as the time-dependent derivative of a function. For instance, the velocity or speed of the item at any given time would be the rate of change of a function that expresses the position of an object over time.
Hello, good morning. My name is Muhammad Ariel Iskandar. My metric number is 08DEP22F1029. So, today I will present about the stationary point. Let's go. Okay, so I will find the stationary point of this question. So, firstly, we must to differentiate the question. So, dy dx equal to 3x power of 2 minus 12x plus 12. When dy dx equal to 0, we must using calculator EKN degree to find the value of x. So, from the calculator, we only have 1x. So, substitute x equal to 2. Y equals to, we must to replace the x to the value that you get from the calculator. And then you get the value of y. So, from our question, the coordinate value is 2, -4.
Nature of stationary point. Y equal to x power of 3 minus 6x power of 2 plus 12x minus 12. We differentiate, we will get 3x power of 2 minus 12x plus 12. And second differentiate, we will get 6x minus 12. And then we substitute x equal to 2 to the second differentiate, and we will get 6 times 2 minus 12 equal 0, and we will get 0 equals 0. The coordinate we will get 2, 2 and -4. That's the inflection point. Thank you. Application that we use for the calculation for stationary point is GeoGebra.
Okay, so now we have to sketch off the graph. So, from the nature of the stationary point, we get the value of our coordinate is in inflection point. So, the graph should be in inflection point. So, to sketch off the graph, we must to find the x-axis and y-axis. So, at x-axis, y equals to 0. So, substitute y equals to 0. It is 0 equals to x power of 3 minus 6x power of 2 plus 12x minus 12. So, we will get the answer is 3 value of x. So, the first x is 3.59, the second x is 1.21, and the third x is 1.21. So at y-axis, x equal to 0. Substitute x equal to 0. So y equals to 0 power of 3 minus 6 times 0 power of 2 plus 12 times 0 minus 12. So the answer is -12. So after we get all the answer, we have to plot the answer at the graph and sketch it, and we can have the graph. Okay, that's all from me. Thanks for listening. So the application that I use to confirm the stationary point and the graph is GeoGebra. You can download it at the Play Store or App Store. It will be more easier if we use the apps and to confirm our answer.
Hi and Assalamualaikum. My name is Muhammad Ahmadinis bin Irvan. Number metric 0822F1060. So, figure 2 show a right circular cylindrical metal rod which is expanding as it is hit. After 30 seconds, the radius of the rod is 8 cm and the length of the rod is 8 cm. The cross section area of the rod is increasing at the constant rate of 0.032 cm power of 2 second power negative 1. And question A is find dx per dt when the radius of the rod is 2 cm. Giving your answer to 3 significant figures. And question B is find the rate of increase of the volume of the rod when x equal to. Thank you for me. Hi and Assalamualaikum. My name is Muhammad Ahmadinis bin Irvan. Number metric 08DEP22F1060. So, I want to explain the question of rate of change, the A question. So, dA per dt equal 0.032 cm power of 2 per second. The rumus dx per dt is dx per dA times dA per dt. A equal pi x power of 2. Next step, dA per dx equal 2 pi x. And then, dx per dA equal 1 per 2 pi x. Dx per dt equal 1 per 2 pi x times 0.032 equal 1 per 2 pi bracket 2 times 0.032. And then the final answer is 2.546 times 10 power negative 3 cm per second, or 0.003 cm per second.
My name is Muhammad Amirul Firdaus bin Muhammad Nasri and my number metric is 08DEP22F1112. So, I want to explain the question of rate of change, the B question. That is, find the rate of increase of the volume when x equal to 2. So, dx per dt equal to 0.032 per 2 pi x. dv per dt equal to dv per dx times dx per dt. So the answer is 15 pi x power of 2 bracket 0.032 per 2 pi x. And when x equal to 2, the answer is dv per dt equal to 15 pi bracket 2 power of 2. The bracket 0.032 per 2 pi bracket 2. So that is time of 2. So the final answer of the question is 0.48 cm power of 3. In conclusion, stationary points and rate of change are important calculus concepts that help us understand the behavior of functions and curves. Stationary points help us find maximum and minimum values, while rate of change helps us understand how quickly something is changing over time. By using these concepts together, we can solve real-world problems in many fields and achieve success in science and engineering.